All right, you should have your lecture notes out for Lecture 5. You're ready to fill in. And if you note, you'll also need to refer back to Lecture 4, some of the things you filled in there. So you should also have those notes out already filled in. Okay, we're looking at descriptive statistics, or ways to describe or summarize a whole set of data. And we've seen relative frequency charts and relative frequency histograms, giving us, the histogram especially, kind of a visual summary of the data. How about some numerical summaries? We have a big data set. Wouldn't it be nice if we could come up with, well, let's just say right now, one number that sort of summarizes the whole data set? So what I'd like is a one number summary of the data. And what I'm going to suggest we should go for there is, say, a typical or average value for the data set. So I just have kind of an idea what would be a typical or average value. What we're really asking for is what we call a measure of center, a measure of typicalness, non-extremeness in the data set, so to speak. There are three standard, measures of center. The mean, the median, and the mode. And I put them in the reverse order of what I just said because they're easiest to more involved to compute. The mode is just the most common data value, the one that occurs, the most common. So in our example, Lecture 4 example, we had what was it? It was the number of phones owned by a married couple with no children. And if you go back and look at that, the classes were 0 through 4, and they had the various frequencies. So I'm looking for the class with the highest frequency, and that's 3. The mode equals 3 because its frequency was 11. Likewise, its relative frequency was 0.44. That's the biggest relative frequency. That's another way to look at it. The value that has the largest relative frequency will be the mode. Median. You arrange the data from lowest value to highest. Median is the middle value. All right, well, if you go back to our example, Lecture 4 example, and you can just look at the frequency chart and figure this out very easily. But the lowest one was 0, and then there was 5 ones, et cetera, all the way out to, there was a 4 way out here. And what you want to do is, because there's a total of 25, you want to go out 12 so that you have 12 more left here. And this value, it's easy to just look in the chart and see that it's it's going to be 2. The 13th value in the data set will be 2, and that's easy to see. So that's the median. What about the mean? Let's see. I'm going to try to figure out where I can fit all this in. Well, the mean, yeah, I guess I'll go up here. I was hoping not to, hoping to save this space for a little later. But the mean is what we typically think of, so this is 3, as the average, when you see the word average. And it just means we sum the data points and we divide by the number of data points. Okay, so we might write that in shorthand notation, sigma, which means sum, and if I just put a little x there, that x means a generic data point, so it just means sum all the data points and divide by the number of data points we have, which I'll just denote with a little n. Okay, so that's kind of a shorthand way to write the mean. And if we think of this as a sample, then what I'm really finding here is what we typically mean by the sample mean, or what we saw earlier was x bar. Okay, well, I would like to look at lecture 4 example and kind of do it the long way. And that is, let's take each data point, add it up, and divide by the total number. So I have a data point of 0, then a data point of 1, 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 then a data point of 1. That's 5 ones. Now I go to, I think I had 7 twos, so it would be plus 2, plus 2, plus, don't worry, I'm not going to keep going. I'm just going to end up at the very last one. So there's a bunch I'm leaving out here. And I'll divide by 25. And if you do that, you get 2.24. This, can you read that? Yeah, it looks like you can. I think that's inside the margin. All right, so I get a data value of 2.24. Now, let me just stop and say we might round that to the nearest tenth. Typically, if you have data given to the nearest integer, you might round to one more decimal point to the nearest tenth and call it 2.2, but I'm going to keep it at 2.24. So we would say the mean or average number of phones that these couples have is 2.24. But there's a better way to compute it. The better way is to realize that I don't really need to add up all the data points. What I need to do is look at, let's say, this data value and just multiply it by its frequency, right? The data value is 0. It has a frequency of 1 in the data set, so 1 times 0 is 0. What about the data value of 1? Well, rather than add it up 5 times, why don't I just take, like here I would take 0 times 1. Here I would take the value 1 times its frequency. For 2, I would take 2 times its frequency. For 3 in here, I would take 3 times its frequency, which was 11, right? Yes. And for 4, I would take 4 times its frequency. So I don't need to write down 1 plus 1 plus 1 or 2 plus 2 plus 2, all those times. I just take it times the frequency. And something even better is the following. Let's break these up. This is all divided by 25, right? So let me think of the sum of all the zeros over 25, and then let me think of the sum of all the ones separately over 25, and then let me think of the sum of all the 2s separately over 25, et cetera, and look at what I really have. The better way is to take the data value times its relative frequency, 1 over 25. The data value of 1 times 5 over 25, which is its relative frequency, which you can get from the table as that. Then take the data value 2 times its relative frequency. There are 7 of them, and I'm dividing by 25. That gives me 0.28, we've seen, plus 3 times its relative frequency, which is 0.44, plus 4 times its relative frequency. Okay, and if we do that, we will get exactly the same answer. You work it out. So look, what we're saying is x bar, the mean, is equal to the sum of all the data values, not the data points, just the individual values, times the relative frequency. So it's actually a weighted average. I take each data value, which is 0, 1, 2, 3, or 4, and I multiply each by its weight, by its relative frequency or empirical probability. And when I multiply them and add them all up, I will get exactly the same thing as if I just simply added them all up and divided. This idea will become quite useful in the future. And now let me see if I actually have room to do the next thing that I was going to do. You know what? I don't think I do, so I'm going to have to pause and just make a part 2 here, and because the next thing is basically just an example, but I just don't quite have enough room. So let me pause and start a new lecture, and that'll just be our example as the second part of this lecture.